So today we're going to look at average atomic mass. Atomic mass is the number of protons plus the number of neutrons in any given atom. All right, so protons versus neutrons. For the first few elements, the number of protons and the number of neutrons are generally the same. For example, carbon has 6 protons, and it also has 6 neutrons. But for elements above atomic number 20, or 20 protons, the ratio starts to change, and you can see that in the graph. The number of neutrons is more than the number of protons. And I'm just going to cite our graph here is from Wikipedia. This is because of the fact that the protons repulse one another and need something in there to kind of buffer them, and that's what the neutrons do. So more protons equals more repulsion, needs more neutrons. All right, so now we're going to look at what isotopes are. The prefix iso means the same. Isotopes are atoms of the same element that have a different number of neutrons. This means that they also have a different mass number, and we're going to look at carbon as an example. So carbon has 4 isotopes, not all naturally occurring. We've got 11, 12, 13, and 14 carbon. They all have 6 protons and 6 electrons, but the number of neutrons is different. Carbon 11 has 5, carbon 12 has 6, carbon 13 has 7, and carbon 14 has 8. And the source from this was Wikipedia. All right, so if we have carbon has 4 isotopes, then why is the atomic mass 12.011 and not the average of those 4 isotopes, which would be 12.5? The isotopes of carbon occur in different percentages. The atomic mass on the periodic table is a reflection of those percentages. So for carbon 11, it's man-made, and it's basically found 0% in nature. Carbon 12 is 98.9% of all carbon. Carbon 13 is 1.1%, and carbon 14 is only 1 part per trillion, so it doesn't really impact the mass. The average atomic mass is always going to be closest to 12, since carbon 12 is the most abundant isotope, and that's always going to be true. All right, so now we're going to do a question. Boron has 2 isotopes, boron 10 and boron 11. Which isotope is more common? If you know the molar mass of boron is 10.81 grams per mole, and you can pause it and answer. And of course, the answer is going to be circled in the end, and it's boron 11. All right, so now let's get into calculating the average atomic mass, and here's the formula. It's going to be the mass of the isotope times the percentage of that isotope in decimal form, and then plus however many isotopes you have. And we're going to do an example of carbon. So carbon has 2 naturally occurring isotopes, which are carbon 12 and carbon 13. The percentage abundance of carbon 12 is 98.9%, and for carbon 13 it's 1.1%, and we're going to calculate the average atomic mass. So again, we're going to take the mass of the isotope times its percentage in decimal form, plus the mass of the isotope times its percentage in decimal form. So 12 times 0.989 plus 13 times 0.11, and we get 12.011, which is what we see on the periodic table. All right, we can do a second type of calculation, which is calculating the percent abundance from average atomic mass. So now let's look back at boron. It has 2 isotopes, boron 10 and boron 11. And it has an average atomic mass of 10.81, which we looked at before and decided there has to be more boron 11. But we can actually calculate the percentage abundance of each element. So we can take the mass of boron 11 and multiply it by its percentage in decimal form, plus the mass of boron 10 times its percentage in decimal form, and it should equal 10.81. We know the two decimals have to add up to 1 since there are only two isotopes. So for the decimals, we can put in x and 1 minus x. So we can set up the algebra here. We've got 11x plus 10 times 1 minus x equals 10.81. And I'm then just going to do the algebra, and I end up solving for the percentages. And x equals 0.81, which is 81%, and 1 minus x is 0.19, which is 19%.